notebook. I see that a couple of students are still pending to join. Let's give one more minute. Meanwhile, people who have already joined, let's open the inbuilt data structures notebook. Today, we will start with sets. We will look at a couple of functions for sets. We'll look at dictionary, and then we will move on to the next module, which is control structures and functions. In case this is your first day, let's open up one Jupyter notebook or a Google Colab notebook. All right. Let's begin with our session. Class, what we are going to do is we are going to continue with sets, but before that, let me tell you the motto of the session. The motto of the session is that no question is silly. Feel free to ask any question that you have with respect to the topic that we are undergoing. After that, I would request everyone to put the questions in the chat. If there is a big question, just raise your hand. I'll request you to unmute. But before that, just try to put it in the chat and let me know if you do not understand anything, if you're getting any errors, etc. Just let me know in the chat itself. Second thing is, let me know if my voice is loud, audible, and clear. Since we are all learning online, it's important to know that everyone is able to hear me. In case you feel that the voice is not clear or loud, just let me know. And if I drop off because of any power issues, be patient for 30 to 60 seconds. I'll be back and we'll continue with the session. All right. Now, in the last session, we would have seen something called as a list and tuple. These are the two inbuilt data structures that are already available in Python. The difference between lists and structures is that the lists are mutable and tuples are immutable. At the same time, we have seen that how to define lists. We looked at a few list functions. Since tuples are immutable, we were not able to perform any operations on the tuple. Now let's understand what a set is. See, set is called as an unordered collection of data types. Now, set is an unordered collection of data types. What does this mean? Till now, the two data types that we have seen, list and tuples, both were ordered collection of elements or ordered collection of objects. It means that if you say, and when you define a list, when you give the first element, that is the element at index 0, as let's say 1, it will always be 1 until and unless you pop it or delete it. It also means that the order in which the elements are present are important. If you look at any list, if you see this list, 20 will always be followed by 10, and this is how the list will be maintained. However, in case of sets, there is no significance given to order. The order is not important. The elements can be stored in any order. Whatever order you give, Python will store it in an unordered fashion. It will never give any importance to the order in which you are giving the elements inside the set. It also means that it will remove any duplicates. So sets are unique. Let us dissect this definition with the help of an example. I'm going to create a set. I'm going to say set 1 is equals to, and let me create some elements. I'll start with 8, 1, 3, 0, 8, 8, 8, 9, 9. Let me say 1, 2, 2, 3, and one more 0. So see, I have some elements which are repeating multiple times. I have elements which are 8, 8, 8, 9, 9, 1, 1, 2. If you define this as a list, your first index will always have 8. Your index number 3 will also have 8. But let's see what happens in set. The moment you print the set, you see that the set has not officially maintained the order that you had given. You started giving the elements like 8, 1, 3, 0 and something. However, Python did not store these elements in the order that you had provided. It will store it. It appears that it has stored it in an ascending order. However, the technical definition is the order is not important. See, order becomes important when you give something in a particular order and Python stores that in its object in that order. Then we say it's an ordered collection. But here we see that Python will store it in an order that deems possible or that deems okay to Python, but it will not maintain the order. And at the same time, it has removed any duplicates that are present here. So let me create another set, set 2. Just for the purpose of an example, I'm going to create a set here with the elements which are, let's say, 7, 7, 6, 5, 9, 7, 3, 1, and let's say 10. If I print this again, you will see that the order is not important. It will remove any order which is already available, and at the same time, it will remove any duplicates. We see that there are no duplicates in this. Let me add a duplicate. Oh, there is 7 which is duplicate. So these are the two sets that we have created. Unordered collection, indicating that the order in which Python stores it is not important. There is no importance given. Since the order here is not important, you will not be able to index it. See, a lot of times people do this and they come back to me saying that this is not susceptible. Now it makes sense why you cannot index a particular set, because the order is not important. If you do set 0, if you are trying to access an element which is present at index 0, it means that this element will always be present at index 0. However, set says that no, this is not an ordered collection of object. So you cannot perform any indexing or slicing on sets. Now there are two functions. If you want, you can quickly define these two sets. Let's quickly define these two sets. And after that, we are going to look at a couple of functions which are available in sets. All right. Now what we are going to do, classes, we are going to look at a few functions which are present in sets. The first function that I'm going to use is called as add. Let me print set one again, just for our reference. You see set one is 0, 1, 2, 3. I can add an element to a set with the help of a function. Since you cannot perform indexing, you cannot determine where this element will be added, and you cannot simply assign the element by giving the value of the index. So what we will use, there's a function which is available. I will say set one dot update, and this, or rather, let me say add. I'm going to say add, and I'm going to add an element, let's say 100 in my set one. The moment I print this, you see that set one, an element 100 has been added. Similarly, if I want to remove an element, I can say set one dot remove. Again, index is not important here. We will directly have to give the name of the element that you want to remove, and the same element will be removed once again. So you can add an element with the help of an add function. You can remove an element from a set with the help of remove function. Now, after this, there is function called as pop. Now, what pop does is, pop here does a very good thing. You should have a question. What can pop do here? See, pop is a function that is used in lists to remove an element at a particular index. In case you do not give any index, it will automatically remove the last element. If we do, I hope every one of us remembers. We looked at pop. If you do not give any index here in case of a list operation, it will remove the last element by default. Here in this case, what will happen is it will remove and return a random element. So let me execute this. You never know what will happen, and it has removed the first element. Please be careful that anytime you execute this pop, add, and remove, the changes will be made in the underlying set. Right? You don't, if you remove an element, it will be permanently removed. You will have to add them using the add function. And finally, so we have looked at add, remove, clear, and one thing that we can do is, sorry, add, remove, and pop. And then we have one function called as set one dot clear. This function, what it does is it will remove all the elements from the set. Sometimes what happens is we do not want to use this set, or you want to redefine the set, you want to empty out the set, remove all elements from the set. What will you do is set one dot clear. The moment you print set one, now you get an empty set. So I'll have to redefine my set one because we will continue with some other operation, but let me do it. When it added one element, it added in between. That's right. See, your element will be added at any location. It can add at any place because the order is not important. See, it was going to behave very weirdly, you might think, but it is not storing in fact, I'll tell you, for me, for you, for or the rest of the students, what will happen is Python is going to store in a random order. That order is something which we do not know. So where it is going to add, we can't say. Mostly it appears that it will add things in an ascending order, but that's not necessary. The order is not important. It can add at any place. Similarly, it will remove by giving the name of the remove element, and pop will randomly pop. So remember, again, when you add, it will randomly at any place. It will randomly add at any place. When you pop, pop will randomly remove an element. See, because the order is not important, you cannot perform indexing. There is no fixed order. That is why this kind of randomness. Let me redefine my set, in fact. Once done, we will need both set one and set two for our next operations. So let's have them handy. Let's redefine them. Set two would already be defined, but let me give you a couple of minutes to try this out. Try out add, remove, pop, and clear. All right. I hope everyone is done. If not, let me know. If not, let me know. Okay. So now we are going to look at a couple of operations which are available in set. And these operations are very similar to what we had in our school days when we said that we are looking at set theory. Does anyone remember set theory? In set theory, there were two operations. One was called as union and the other one was called as intersection. Right? So we are going to look at these two operations. The set theory that we studied in school is applicable here as well. We are talking about the exact same sets. So in case of union, what will happen is we know that it will return all the elements by unionizing them, right? And then in intersection, you will receive all the elements after. Okay, so let me write it now. Set 1 union set 2. What will happen? You see that all the elements which are available in both the sets will be returned. So all elements will be combined. Okay. Now, do you observe that it creates a new set? It will automatically create a new set. A union operation and an intersection operation always creates a new set. You can assign it to a new variable as well. I can say, let's say union set, and then I can print it as well. This, if you check the type, you will see that it is a set. Now, another observation that we see here is that 0 is present once, 1 is present twice, but when you create a set, it will always remove all duplicate elements. That is why 1 also gets removed by default. Right? So you see just 1, 1, you see 1, 3, although you see that there are 3 in both the sets, only 1 will be placed here because by the definition of set, it will always remove all duplicate elements. Similarly, can someone tell me what does intersection give you? What will intersection give you? Can someone tell me? If I do set 1 dot intersection set 2. It will give me the common elements. That's perfect. Yes, perfect. So it will give me the elements which are common in both the sets. I can assign it to a new variable. I'll say intersection set to indicate that the output of an intersection operation as well is a set. So it says that between set 1 and set 2, I have three common elements, 1, 3, and 9, which is present in both the sets. So intersection will give you common elements in the two sets. Let's quickly try this out. Let's quickly try out both union and intersection. All right, so I'm going to assume that we are done. I have one more function that I can tell you for sets, which is called as update. It will add elements from the second set to the first set. Let's see, set 1 dot update set 2. What it will do is the moment I execute this, if I check set 1, what has happened is it will assign all the elements which are present in both the sets. So basically what it has done is it has taken the elements which are present in my set 2 and have appended them to set 1. That is why the output, although it appears similar to that of the union operation class, it's not exactly the union operation. See, when you perform the union operation between set 1 and set 2, a new set is created. In case of update, what will happen is all the elements which are present in set 2 will be updated as values inside set 1. So the set 1 itself has been updated. All the values are present here. So update, it will add elements from the second set to the first set. Let me say all elements. And the being the property of sets that duplicate values are not present, you will see that all the duplicates are removed and you only have unique elements present here. Let's try out this update command as well, and then we will move on to dictionary. All right. So class, we are going to now start with our fifth data type. I think we have seen at list, we have seen tuples, we have seen sets, and now let's say the fourth. We have seen strings in I think back to back, 2 sessions back. But these are the inbuilt data structures. So on that matter, I'll say that this is the fourth data set which is available. Dictionary is nothing but it is called as the implementation of associative array. So let me say it like this. It's Python's implementation of associative array. Right? In simple words, it's nothing but it's a combination or a cluster of key value pairs. So let me tell you what is the difference between dictionary and why did dictionary come into picture. Let me go to, let me see if any CSV is open. Yes. Let's come in. Okay, I think this is something which we studied in the last session. We'll continue in this. See, at the moment, let's say if I give you names of 5 students, A, B, C, X, Y, Z, let me say D, E, F, let me say L, M, O. Okay, these are the 4 students which are available in your class. Now, what will happen? These are the values. These are my elements. These are my values. These are strings. These are the values. Now, by default, Python will give you the index saying that this is 0, this is 1, 2, 3, and so on. But there might be cases wherein you don't want the indices to be available as 1, 2, 3. Rather, you want that these names should be represented by something else. Let's say I want to represent them by roll numbers. I want 101 to be represented as ABC, 102 to be represented as XYZ, 103 to be represented as this, and 104 to be represented as LMO. This is what my requirement is. So basically what I want to do is instead of indexing it on 0, 1, 2, 3, I want to create my own customized index. This value is called as the key. If I want to create my own key through which I want to access. So what I want to do, let's say I'm going to call it as, let's say class is a keyword. Let me say A. Let us use that this is an object A, where A of 0 ideally should be, I can say that A of 0 is equal to, let's call it dict, rather let's call it dict1. Okay, I'm going to call it as dict1, and what I want is instead of saying that get me the first element, I want to say that get me the name of the person who's at value 101, and I want the output to be ABC. Similarly, what I want is dict1, I want whoever is 102, I want to customize that how I want to access my values. I want to access my values using these numbers. Okay, or it can be the reverse as well. Like you in keys, you can define anything else. Let's say I want to refer to them by A, B, C, D. You can do that as well. But what we are trying to do is we are basically trying to customize our index values, and we are going to say that instead of these indexes, let me use these keys. When you want to create such kind of objects, you always use the combination of key colon value. It means 101 colon ABC is how you're going to define this particular object. So what I want to do is I want to create a collection or a cluster of key value pairs. I'm going to say 101 is ABC, 102 is XYZ, 103 is DEF, and so on. So let's go back to our Python notebook and see how do we define the dictionary. Let me say dict1 and let us take the same example. Again, dictionary is defined in curly brackets, and I'm going to say 101. I'm going to say ABC. So do you see this is the key value pair? Now, in this key value pair, I have whatever I have before the colon is called as the key. Whatever I have after the colon is called as the value. So basically, I'm going to say that in my dictionary, the key 101 refers to the value ABC. And I'm going to add comma separated key value pairs. Let me say DEF. Let me add just three values for simplicity. 103 is XYZ. If I do this, let me print dict1. Let's revise. Does anyone remember how can I check the data type of my variable? What is the name of the function to check the data type? Whenever we do define a new data type, this is the first thing that we check. Anyone remembers? Or should I go ahead? I'm going to use type. That's right, type. So I'm going to use type dict1, and the moment I check, it will give me dictionary is a data type. I can check the length. Now, length in case of a dictionary will give you the total number of key value pairs. See, length in case of different data types. I would have mentioned this every time we look at length, that length is a universal function. For different data types, it will give you different values. For a string, it will give you the total number of characters which are present inside that string. For list, it will give you total number of elements. For tuple also, it will give you total number of elements. For set, it will not work. Did it? Please try. Someone, if you're available, try it out. It should ideally not give you any value. See, people generally do not want to work on set, but it will give you the total number of unique elements which are present inside your set. And here in this case, length will give you the total number of key value pairs. You see, we have 3 key value pairs, and that is why the length of this dictionary is 3. See, generally, I do not prefer to go for a length of a set, but if you calculate the length of the set, you will have to remember that it will give you the number of unique elements which are present inside your set, but avoid using the length of a set. Similarly, length in case of a dictionary will give you the total number of key value pairs. Let's quickly define a dictionary, check its type and check its length, and then we'll go ahead and look at different functions which are available in dictionary. Yeah, great. So now we are going to look at a few functions. The first thing that I want to show you is if I do dict1 and I try to index 0, what do we get is there is no key called as 0. So we always have to remember that you need to give a key which is already existing. The moment I give T101, 102, it will start returning me the corresponding values. Now what we can do is we can use the function So we can use the function called as dict1 dot keys, which will return all the keys which are available. So to get all the keys inside the dictionary, you can use the function keys. Python is a high-level programming language. I think I would have mentioned this multiple times. It means if you want to get something, the function name will most probably be simple English. If I want to get all the values which are present, I can simply use the function called as values, and it will give me all the values which are present inside the dictionary. Now, I can see you can either print dict1, it will give you all the key value pairs. There is a function which I generally do not use, but you can use items, and it will give you a list, rather a list, or most probably an iterable object of what are different items. It will return all the items. This is a function which I would say is useless, but if you want to know, you can always know. So these are the three functions, and I'm going to tell you a couple of more functions, but let's quickly try this out. You need to understand how to perform indexing in a dictionary. You will always have to use an available index, an available key. Always use a key which is existing, because the idea of defining a dictionary was I do not want to use 012, which is the default Python index. I want to provide a key, and I want to access values with that particular key. Then to get all the keys inside the dictionary, you can use the function called as keys. To get all the values inside the dictionary, you can use the function called as values. And then finally, you have items. Items, for me, to be honest, I should not be saying this. It will be used whenever you want to perform any iteration over dictionary items. But generally, if you just type dict1, you can see what the dictionary is. All right. Now let us see at functions called as update. What will update do? If you try to run update function on an existing key, if the key is existing, it will update the value for that key. Right? So let's understand what I'm trying to say. Before that, let me print the dictionary so that we can use that for our reference. You see, I have 101, 102, and 103. What I can do is I can simply execute a code called as dict1.update. And I will say inside a curly bracket, I will say 101 colon, let's say I update this to LMO. The moment I do this, what will Python do? Python will go inside this dictionary. It will look for, do we have 101 which is already present? So 101 is already an existing key. It will update the value of this particular key to LMO. So if the key is already existing, the corresponding value will be updated. Now the question appears is, what if I add a value which is, or I add a key which is not existing? Let us add 104. The moment I say 104 and let me add some value, let's say PQR, if I execute this, what will happen is it will insert a new element 104. So what does update function do? Update function will add a new value, add a new key value pair rather, if the key does not exist. And if the key is already existing, it will simply update that key with whatever value you have provided. Let's quickly try this out, the update function. Let's try out update on one existing key and on one new key. All right. There is one more function class. That function is called as pop. I'm not a very big fan of this pop function. Never have used it in my life till now because this function will do what? See, pop function has been doing the same for all. It did the same thing for list. It did the same thing for set, and it will remove an element here. But in this case, see, in lists, pop was accepting a parameter, and that parameter was the index value. Set is an unordered collection, so it does not matter, it will randomly remove an element. But in case of a dictionary, instead of the index value, see, we have totally forgiven the index value. There is nothing called as index, everything is key. So if you give a key, right, if you give a key value, you will see that your dictionary has removed that particular key value pair. So if you want to remove a key value pair, you can always use pop, but please remember that pop function in case of dictionary will take as input the key. I can't say value now, but the key. So it will take 101, 102. It will have to take a key. I'll say remove the key value pair with the given key. Also, I see sometimes students get confused that the keys can only have numeric data and your values can have only string data. Not true. Your keys can be of any data type, your values can be of any data type. That does not matter. It simply means that if you want to refer to a particular value, you will have to index it using the given key. All right, class, if you are done, what we can do is please open a new notebook. We will start with control structures. If you are done, we can start with control structures. No issues, Binay. Issues. Do not worry. What we have done is we just looked at two data types. We had looked at sets. We have looked at dictionary. You can go through the session recording once and let me know if you have any questions. Will that work? We can have a revision session at the end, maybe, where we can take any questions that you have. All right. So if everyone is done, what I would request you is to open a new notebook, and we are going to start with something called as control structures and functions. Of using underscores everywhere. This has come up because of Python. All right. So if we are done with dictionary, people please come back to the screen, and we are going to start with something new now. We are going to start with the first thing, which is called as conditional statements. Now, conditional statements is a very simple concept. The statement says that if my condition is true, you perform certain task. Let's say perform task 1. If it is false, that means else. What does else mean? Else here means that if the condition is false, right? If the condition is false, perform task 2. Okay, so conditional statements are nothing but these are the statements that will determine how your flow of control should go ahead. If this particular condition is true, you want these statements, and this task 1 can have multiple statements. Let's say there are 100 statements which are present here. So you want to perform these tasks if a condition is true, and you might want to perform some other tasks when the condition is false. That means and we are going to see in I think hopefully by the end of this session, it will become very clear what is condition true, what is condition false, when we can have a requirement that one condition is true, one condition is false. But in general, there are two different tasks that have to be performed, and it's based on a condition. Right? In that case, you can always use if else condition. Now, please note, class, that whenever you have if the condition is true, all the statements that are associated with if will be executed and nothing in the else will execute it. See, if your condition is true, your flow of control will always go here and it will stop there itself. So let me write down. Let's actually do it with the help of an example. Okay, so let me do this. Let me define variable a equals to 20 and b equals to 10. Okay, and what I'm going to do is I'm going to say if a is greater than b. Okay, let me say if a is less than b. Okay, if a is less than b, we are going to learn three things in this particular cell. The first thing is conditional statements. We all know what is the output of our conditional statement. What will be the output of our conditional statements? You would have seen conditional operators in the first session. The output of your conditional statements is always a Boolean type. You will either have true or you will have false. I hope you remember we would have seen in the first session less than, equal to, greater than, equal to, and not equal to. These are the 6 conditional operations, and you will always have some or the other operations which are present here. So you will check if a is less than b. In that case, I want to print that, let's say a is smaller. I will again print that I am in if part, and I will print, let's say, one more thing, that the condition seems to be true. So the condition is true. Let us reverse these statements. What I'm going to do is a is smaller, the condition is true, and that is why I am in the if part. Now, class, I want you to pay very close attention to what I have done. After I gave if a is less than b, it's optional. If you want to give bracket, you can give bracket. If you don't want to give bracket, that is also completely fine. Whenever there is a single condition, you go ahead and do not give any brackets. Whenever there are multiple conditions where you have to give and or, prefer to give brackets to avoid any confusion. Okay. Now, let me go ahead. Let's dissect this code. I have given if statement and one condition. After this condition comes the most important concept of Python, which is the colon. Till now, you would have observed that Python does not have any semicolon. If you are aware about any programming languages, especially C, C++, semicolon actually forms a big part of this programming language. However, in Python, there is no semicolon, there is no colon, nothing else, right? You simply have one thing which is called as colon that is used to define the scope of the upcoming statements. That's it. Your enter is something which will tell Python that the previous command has ended. See, when I wrote a equals to 20, in the next line I have written b equals to 10. Python is smart enough to understand that a equals to 20 is my command 1, b equals to 10 is my command 2. Wait, if I write down anything else, let's say if here itself I write down c equals to 100, Python will get confused. Python will not understand what you're trying to do. So there is a certain syntax which is associated wherein you write down one command at a line, press enter, go to the next command. That's it. One command per line is what you will write. Sometimes the commands are longer, you will have to write down it in multiple lines, that is okay. But the enter statement indicates, this enter basically indicates to Python that the current line and the command has ended, and we are going to the next command. In the first command, you have created an object 20 and assigned it to a variable a. In the second command, you have created an object 10 and assigned it to the variable b. So when I say created an object 20, it would have gone inside Python memory, looked at a particular empty memory, assigned that 20 value, created that object, and then came to the left-hand side of the assignment operator and created a variable a. Right? Similarly, this colon now, why does it play an important role? Because this colon will tell Python what is the scope of if. See, if you have one condition which is true, you can have one statement that you want to execute. You might have 10 statements that you want to execute, or you might have 100 statements that you might want to execute. Is that true? You don't know. And Python does not know. Python would want to know that how many statements or how many commands I should execute if this condition is true. Enter, this colon. Okay, so what does this colon do? This colon will tell you that the successful lines, the succeeding lines, all the lines that you see below, which are coming with an indentation. Now, what is indentation? We'll come to that. But till then, just remember this term that everything which is coming within indentation is a part of my preceding command. So it says to Python, if you look at this particular example, that all these three statements are a part of my if. Why they are a part of my if? Because after colon, I have indentation. And what is indentation? That I am not writing the command immediately after if. You see, there is a space, and this space is fixed. This is the amount of space. This is a tab that I have entered. So if I write down any statement, let me show you. If I say if A is less than B, the moment I press colon, and this is what I'm going to do, I'm going to press enter. Do you see that automatically Python and Jupyter Notebook will push me a little bit ahead? Now I can write down anything. I can write down A equals to A plus 5, whatever I want. I can keep writing whatever I want to do, right? A minus, then I will say A equals to B minus A, whatever I want. I can keep writing the commands. It will tell Python that if this condition is true, execute all those commands which are coming with this indentation, with this tab, right? And the moment I go back, right? The moment I go back to my previous indentation, see, here I have one indentation, right? Then the moment I go back and I say else, what does it indicate? That my if statement has ended here. This indentation tells Python that the if statement has ended. Go back to the next statement. This else is not a part of if. Okay. Or let me say simply, I am not even worried about else. I'll say that if my condition is true, you execute these three lines as they are indented. And once you come out, what will happen is you print I am outside my if statement. Now see, let's understand how will Python execute this. If you see, it has only executed one thing, which is I am outside my if statement. What happened? Python came here is if A less than B. Is A less than B class? A is not less than B. This condition became false. So Python did not execute any statements which were in the scope of if. The flow of control directly goes outside the if. Outside if, it executes, it identifies, it finds a line called as print. I am outside my if statement, and it will print I am outside my if statement. All right. So what did happen? Once again, class, what happened here is if A is less than B, the condition became false. These three indented lines, this colon and these three indented lines indicate that these three lines are a part of if. They will be executed only if this condition is true. But now, since our condition is not true, the flow of control does not go inside. Rather, it comes outside and goes to the next line. Now, the question is, how does Python identify that this is the last line or this is the outside if? Because the indentation has gone. Do you see that the I of if and the P of print are exactly one below each other, indicating that this print statement is not inside if, but it is outside. Now, if I check the reverse condition, what will happen? You see, if this condition becomes true, the flow of control will go inside this. Okay, let me write down another example because I don't want any confusion. Let this have just I'm outside if A is larger. Okay. Now, what happens in this case is if I check if A is greater than B, right? If I check if A is greater than B, the condition becomes true. The flow of control will go inside and it will execute all the statements that are inside the scope of my if. It will say A is larger, it will say the condition is true, it will say I am in if part, and so on. Once all the statements have been executed, the flow of control will go outside the if and you will come outside if. How do you know that you have come outside if? Because the indentation has ended. The I and P are exactly one below the each other. So you know that this statement P is not a part of if. It's outside. So irrespective of whether the condition is true or false, you see anything which is outside should be logically executed. But your colon will tell you what is the part of which is inside. Does that make sense, class? Do we have some clarity? Don't worry, we are going to write down a lot of codes with colons. But I hope there is some amount of clarity of what if is, what is a conditional statement, why do we use colon, and what is the meaning of indentation.
Sorry, Ankit, for interrupting you.
Yeah, tell me.
So A equal to 20 and B equal to 10. Like I gave A equal to 10 and B equal to 20, and if condition A is less than B. Okay, in that case, I gave like as usual, like what you said, like
Hmm.
four statements within if three and outside of if is one.
Hmm.
So when I run the script, it shown like four results. It should show only three, right? Why it shown no four?
Yeah, it
Like for
should
you
print
also.
this outside line as well, right? Are
Yeah.
you asking why is it printing
Yes.
this outside
Yes.
line?
Yes.
See, once you're okay, now consider this to be command one and this to be command two. How here you have command one? Let me comment it down. This is your command one. CMD is your command one, okay? And your command two is this. Now, once your command one is executed, does Python go and execute the command two? Yes or no? Once a equals to 20 is
Yes.
executed, it goes to the next logical command, which is b equals to 10, and it executes. Now, what I'm going to say is this if statement complete till this part is my command one, and this
Yeah.
is my command two.
Okay.
Okay, so what happens is if your if statement, see, your command one will be executed when your if statement is true, it will execute the entire command one. See, a lot of people might put it like this. I see some of the authors there have put it like this that this is command one and this is command 1.1. Right, first Python will execute this condition. If this condition is true, it will execute all three statements, which is for true, and then it will move on to the next logical command, which is just outside the right? You can have multiple commands after this. But I don't say it like that. What I'll say is this is entirely one single command. Okay, I'm going to say that this is one command. Your if statement is one command. Now, if statement will be executed always. You will see if A is less than B, A is greater than B, the condition will be executed always. If this condition is true, everything that lies in the scope of if all three lines will be executed, and Python
Yes.
would have completed your command one right? If your condition is false, Python will say that no, I don't have to go inside. It will stop the execution of the if loop then and there, and still
Yes.
your command one is completely executed. Do you
Yeah.
agree with this part?
Yes. Yes. I agree until this.
Yeah. And then it moves on to the next command, which is your print statement. So this is the next logical command. That is why it
So
will always execute.
yeah, this will be always executed. Then output will be confused, right, for the person who wrote this query or sorry script.
No, so see, you will never write down one if statement in one cell. Like when you start writing functions, you will actually write down a lot of commands. So let's say I'm going to say total is equals to a plus b. Right. Let's say then I want to print total. Right. So this is just for a studying purpose because I wanted to show you that this statement will always be executed whether the condition is true or
Is
false.
okay, understood. Like if we forget to keep else statement else syntax in the syntax, if we forget to keep else, it automatically repeat the print statement whatever we keep after a loop. like
Yes.
like that you want to state this command, right? This comment.
Yes. Yes. That will
Yeah,
be.
it's clear, thank
Okay.
you.
Okay. So
Irrespective of the logic, it will show the result.
yes, irrespective of whether the condition is true or not, your logical flow of control will be once you go outside, once the indentation stops, it means you have reached the next command and it will always execute the next command.
Sure, thank
All
you.
right. Now, with that, what I want you to do is I want you to quickly try this out. I think Vinay has already tried this out, but rest of you, once you try this out, and then we will go to if else. So, till now, what I wanted to show you is if condition can independently exist. It's a simple thing. If a condition is true, do this. If it's false, don't do anything. Till now, this is what we are saying. If a condition is true, do this. What is this? This will be indicated by these three indented lines. Also note that when you're writing this indented code, your PPP, the indented codes should all be one below the other. If you write incorrect indentation, even a small space or a small tab will cause and you will get an indentation. Okay, so your indentation has to be perfect because if you give another indentation here, it means that you're trying to say this statement is a part of this, but there is no colon and Python gets confused. So be very careful. Going forward, we are going to write a lot of indented code. With practice, you will get used to it, but let me know if you are still not clear.
And what should be the reference for keeping indentation? Like as you said, like it started under a, like whatever the statement which start after if, we should consider that as a point for like writing parent or something, or else any particular kind.
Can you repeat, Vinay? Can you come again?
Yeah, indentation means like after if statement, whatever the first letter or first syntax line, from there we have to keep a print statement, right? For
Yes.
that if condition. And if else means, how can it be like?
Else, the else part you are saying after if the else
Yeah,
part, right?
yeah,
Yeah, we'll come to it immediately after.
yeah, sure. Thank you. I got you. Yeah.
Let me know once done. Let me know once done. Ignore this part. This is something which we will continue. But I want everyone to try this out. I want of you to get a hang of what indentation is, what is colon, and everything. With practice, it will become very easy. After some practice, you will forget about everything and you'll write down code like anything. But for today, since this is your first code, I want all of you to try this and let me know once done. I think Vinay is already done. Rest of the class, let me know once you are done as well. I'll give you 1 more minute for everyone to try this out. In case if you get any error, just let me know. Do not hesitate if you get any error. All right. So class, now I want everyone to be back to my screen, please. We have seen if A less than B, and I wrote down these three statements. Again, let me repeat. I'm going to repeat it multiple times till this goes inside and subconsciously you start understanding it. It means that if A is less than B, I'm going to say that if this condition is true, then in the scope of A, I need to write down three statements. My first statement is that A is smaller. All right. Then I want to write down print the condition is true. And I want to write down I am inside the if part. Now, what happens when the condition is false? We know that if the condition is false, everything within if will not be executed. These three indented codes indicate that these three codes are to be executed if the condition is true as a part of my if statement. Now, let's say, what if the condition is false? There are two things that will happen. Actually, in fact, let me say that there's one thing that's going to happen, and that is that it will automatically come out of if and go to the next command. Now, in the next command, you can always give else. What does else do? Else, as the English word indicates, in Python, it's a keyword. If your condition is true, execute these three lines. If your condition is false, you can then give a keyword called as else, give a colon, and execute whatever logic you want. I can say A is bigger, right? I can print the condition was false, and I can print that I am if inside the else part, right? And then I can have another statement saying, let me write down command 2, which is I want to print something. I am outside if else part. Now what happens here? Let's understand. So now I have two commands. I'm going to still say class that I have two commands in my code. My first command is the if else command. If else command indicates here that if my condition is true, these three lines of code will be executed. If the condition is false, whenever the condition is false, the flow of control will go to the next logical statement, which is else. It will see that, okay, the condition is false, then execute these three lines. Now, in this case, what happens, classes? See, here what we were checking is if the condition is true, I want to do this. It's as simple as that. If the condition is false, I don't want to do anything. Is that right? When you just write down an if statement, what you are doing is you're checking if the condition is true, I want to execute this. That's it. You stop there. But whenever you want to execute a code that if your condition is true, execute some commands. And if your condition is false, in that case, execute some other commands. So it means that either of the one group of commands is going to be executed. Either you will execute these or you will execute these. And once the execution is done, the flow of control will come to the next statement, which is here I am outside the if else. So you see I, E, and P, all three fall in the same indentation, indicating that for if, these are the three statements, the indented statements that have to be executed. For else, you have a colon here, and the indentation indicates that these three statements have to be executed. And this is the next command. Now, after this, you can keep executing. So this is my first command, and this is my second command. If I execute this code, what will happen? See, the condition A is less than B is true. Okay, so this condition is false. So what happens is the flow of control goes back here and it prints A is bigger, the condition is false, and we are inside the else part. Let's quickly try this out, class.
Ankit, sorry to interrupt you. Like in print statement, like if we keep a plus b, it will sum, right? The same way, do we have any chance to keep any conditional statement inside of print? Is that execute as expected?
Hey, Vinay, give me 1 minute. I saw your question. Give me 1 minute. I'll come back to you. Let me know other people. Are you able to solve this question or not? Were you able to execute this code successfully or not? All right. So if A is less than B, print A is smaller, print A. I tried like this and gave the result. A is big, the condition is false, and I'm not in if part 70. I understood your statement. All right. Vinay, can you repeat your question? Sorry, I missed it.
Like in print statement, like after keeping if and else, and I kept like as you kept print, I'm outside of if else. Like you kept the same way I tried just a plus b,
Yeah, it will execute.
and it provided the result of sum of a and b.
Yes.
What I gave, like the same way, do we have any chance to keep same if statement inside of the print? What else, like if we keep, what would be the error, and do we have any chance
No,
of
so see, print is a function that will only print whatever you give inside as a parameter.
yeah,
Right? So
but it did the arithmetical operation, right?
yeah, it will do an arithmetic. Okay, it will do an arithmetic operation. That is true, but you cannot have a if statement inside a print. I will show you one example of how you can do it. You will write if, and then you can give a print. But inside print, if you give an if, it becomes really complicated.
Yeah,
Okay, because it will not execute conditional operations. It will execute all your arithmetic operations. The output of if is going to be Boolean, right? And you will have a long, long function. You cannot have a single line. Print will accept a single line of input.
yeah.
Okay, so arithmetical operations is fine, but your conditional operations is not.
Okay, got it.
Got it?
Thank
You
you.
see, if you do print A less than B, what you will
It
get
will work.
is after output, it will
False.
give you the output, which is a Boolean
Yes.
output.
Yeah.
But it cannot do if. The moment you write if, what happens is the syntax will not allow, because within if you need to write down a colon, and then where will you write it? Python will never be able to understand what you're trying to do. The
Yeah.
indentation will not be possible here.
Yeah. As you said, I tried the same, like a less than b. I tried, and it showed the result. It shown the result. So that's the reason I thought of asking you if and else statement. Why it don't express the same? Like both are boolean, but output we are keeping as print statement, and we are giving some content inside of it. But
Right.
end of the day, it is like a boolean result, and it's showing some print statement, whatever the way, whatever the statements which we are keeping inside of it.
Right.
Just I
That's
thought of checking it, but yeah, I understood now.
good.
It will be complicated, and it will be, it won't be work, I think.
Yeah, it will not work because syntactically Python will not understand what you are trying to, where is the indentation, right?
Yeah, but it will show the result of that boolean expression.
Yes,
Uh,
all the arithmetic operations, Boolean operations, string operations, all these will work. But if else, for loop, all let's say control structures will not work within print.
okay, okay, got it. Clear. It's clear for me.
All right. So
Yeah.
with
Thank
that, class, let's do one thing. We have seen, now I'm going to write down a code where A is less than B. Let me print out simple statements. Print A is less than B. A is smaller. So let me print like this. Let's start if A is equal to B. Vinay, I request you to go on mute if that's possible, please. Thank you. So what I'm going to say, if A and B are equal, I would like to print A and B are equal. Else I'm going to say, now within else C class, what I'm going to do within else. Let's focus here. Let's ignore this particular output false and see. So now what I'm going to do is within else, I am going to write down one statement which is called as if. And I'm going to check if A is greater than B. Now see what I've done here. I am writing one if statement, and if that condition is true, I want to execute certain piece of code. If that condition is false, I want to go into else. But after going into else, I want to check another condition. If A greater than B. Now what I did is I gave a colon here indicating that the following lines which are indented will lie in the scope of else. So Python will keep executing all the lines of code within else till you give indentation. Now the first line it encounters is a if statement. Now if in itself is a control structure. So the moment you give colon, you have to give another tab or another indentation to indicate that this print statement or whatever code. So I'm using print statements to indicate any logic that you can write. Print is something which will help us to understand the output, but there can be any logic. But that logic has to be written in an indented manner. Now I can print A is greater, right? Or let me say, because we already know that A is smaller, A is greater. Let's write down A is smaller. Okay. And within this, I am going to write down another else, wherein I will check if A is greater than B, then I want to print. See, this is not a very optimum code, but we need to understand a concept for which we will be using this particular code. And I am going to say A is greater. Okay. So now what do we see? Let's go through this code once again. If A is equal to B, I'm going to print A and B are equal. If the condition is true, my Python will see that you have given an indented code which will print A and B are equal. Now, if the condition is not true, the flow of control will go to else, right? And once it goes to else, what I will see is I have these many codes that have to be executed. Right? Within else, you see till I have an indented code, till I have this indented code. That means until and unless I find a code which is exactly below this E, everything else will be a part of else. So how does Python identify? Why I am saying that all these statements or all these commands are a part of else? Because until and unless Python sees some code which starts exactly below the LE of this else, all these codes will be a part of else. Now within else, what do you see? Within else, you see one more if statement. So this if statement comes, that is possible, right? Now one condition was not true. So you want to go inside the else, but within else, you want to check some more conditions. See, if A is equal to B, you say, okay, this condition is false. Now A can either be smaller or be greater, and you want to check that. So within else, you will give another if statement wherein you will check if A is smaller than B. Again, you give this colon and you give the logic. Now, just see, simple way of understanding what is within the scope of this if. Until and unless you write something exactly below I, all these statements will fall under the scope of if. So this is one if statement. The moment if this condition is false, if A is less than B, this condition is true, you will execute A smaller. If this condition is false, the flow of control will go inside this else. It will check, okay, I have another if. So all these if statements, the next following statements will be under the scope of this else until and unless it finds something exactly below E. It will keep executing, understanding that everything that you have written is within the scope of else. Now within else, again, you have if. Within this if, you have one statement. So what we have written is this is an example of nested if else. Right? Nested if else means what? Within else statement, within an if else, you're writing another if else, and within that else, you see you have written another if else. So it's like a nested structure of if and else statement, one inside the other. But I hope you understand now with the help of indentation, you can clearly understand that this print statement is a part of this if, indicating that if A and B are equal, this is what your condition is true, this is what will be executed. If the condition is false, the flow of control goes into this else, and then you have to execute all these codes. Now, Python has not seen these codes yet, but Python knows that, okay, I have to execute these codes because if I find something exactly below E, I will understand that the scope of else has ended. But since we have not written anything, we can write something here. You can print or write any piece of command here, but that will become the logical next command. Now, in this else, what will happen? You have written down if A is less than B. This again is a new if else. If you look at this, right? If you look at this particular piece of code independently, this in itself is a if else statement. So you have written one if else statement, another in another if else statement. So that's why we call it as nested if else. So you write this, this is the scope. For the else statement, these lines are the scope. Again, for if, this is the scope. So we have written if, else, if, and you have written the code. Once you execute, you will reach here because A is greater than B. The first condition is false. The flow of control goes inside else. Within else, it encounters the first if. This condition is also false. So it goes into the else statement, checks the next condition. This condition becomes true, and you print A is greater. Let's quickly try this out and let me know if you understood the concept of nested if else. Let's try this out. Let me know once done, class. Let me know once done. A equals to 50, B equals to 20, C equals to 70, if A less than B, else if A less than the statement for true. Yeah, that's fine. See, the reason why we have done this, there is a logic that we are going to see in the next statement. If A is less than B, then print B is bigger than A, else print if A is greater than C, print C. Your first condition is false. A is less than B is false. So it goes into else. If A greater than C, that is also false. Then you will check if C is less than B, then in that case, that condition is also false. That's right. So you will not get any output because none of the conditions were true. This piece of code will not give you any output. Python will come out without any output. C is smaller than B. Yeah, that's actually a very good code winner. So your code, all your if else statements are getting executed, but it's giving you no output. All right. So see, I see that Subha is done, Subhalakshmi is done, Vinay is done. Rest of the class, let me know if you have any questions. If you are facing any error as well, just let us know in the chat. You can post the error or the code that you have written down if you are facing any error or if you have any question. Okay. Now, see this statement, although the nested if else statement is something which is very useful, but if you see it's very complicated to read. It's not maintainable, it's not readable, and it's confusing. So Python developers, now see, the most of the Python codes have been written down by open source Python developers. Okay, the Python developers themselves have developed the entire language. So what they came up with is, I can do this. If A equals to B, I will say exactly same code I'm going to write down, but in a separate manner, where we are going to look at a new keyword which is called as elif. See, whenever you have this else if, that means within an else, when you want to check another condition, right? Whenever within an else you want to check another condition, what you can do is you can simply use something called as elif. And within elif, you give the condition if A is smaller than B, print A is smaller. Elif, again, see, instead of this else and this if, what I'm going to do is I'm going to combine them together and I'm going to bring them outside my previous statement and I'm going to say elif A is greater than B, you print A is greater. And it will give you the exact same output. But if you compare the two codes, this code is far more readable and maintainable. See, when you're writing multiple nested if else, you see that the indentation, sometimes you might end up making an indentation mistake, or Python might get confused. There might be multiple nested if else which are available. But Python says, the Python developers, what they have done is if you have else if, that means if there's a code wherein you want to check one condition within the else statement, what you can do is you can simply use this elif statement. So if your condition is true, it will execute. So how this code will work? First, it will check if A is equal to B. If the condition is true, it will print A and B are equal. If the condition is false, it goes outside this if, it encounters elif, it says, okay, I have to check a new condition. It will check A is less than B. If this condition is true, it will execute A smaller. If not, it will go outside this else and come to the next elif statement, wherein it will encounter A greater than B condition, and it will print A is greater. This is much more readable, maintainable code. That is why we have this elif. All right, I think with that, we are exactly on time. There's one more way you can write down if else. That is as simple as an English language. This is something print, but that is something, let's do that when we study lambda functions. I think for today, we can call it a day. For today, we can call it a day. Let me know if you have any questions, if you have any errors, we can resolve that, else feel free to drop. All right, I think we can call it a day then. Thank you, everyone. Great day. We'll see you again on.
Sorry, Ankit. Like as expected, everything is completed as of now, right? As of today, like scheduled stuff.
No, so we are slightly behind. We should have completed the definition of functions. So for loop and functions is something which we should have completed today, but we are slightly behind schedule. But we'll cover up in between. Don't worry. There are a
Yeah.
few sessions in between where we'll speed up. These are simple sessions wherein we'll cover up for whatever is the time. But we'll not leave any topic. See, I believe that it may take some more time, but we should do things in detail.
Yeah, and I'm sorry for interrupting you at the time of session. And
No worries,
if
no worries.
if you are okay, I can ask you. I'll ask you end of the session, like while at the time of log off. Sorry for
Anything is
interrupting.
fine with it. Anything is fine. See, that's why I said you can put it up in the chat or you can raise a hand. If because sometimes you will have doubts that need to be cleared at that moment itself, right? You can't wait till the end. That is why if you have questions, feel free to ask. That is completely fine.
Yeah, but because of me, I feel like a session is getting delayed or
No
something.
worries, then. No worries. We'll cover up for it. Don't worry. See, because the important thing is that for everyone, the concept should be clear, right? If it is clear, we are achieving our objective. Let it take time. That is completely fine.
Sure, Ankit. Thank you so much for understanding us.
No worries. All right. Thank you, everyone. Bye bye. Good night.